Right, we are going to be focusing on the May-June 2023 IEB Assessment Mentors Exam, Mathematics Paper 2, 3 hours, 150 marks. I'd be interested in us focusing on all the questions, but quickly I'm going to comment on each question and just give a hint and the answer to each question so that you can have an idea actually on how this paper should be solved. The data below gives the year marks out of 100, which are percentages then, obtained by 8 pupils in mathematics and physical science. Use your calculator to determine the equation for the line of best fit in the form y equals a plus bx. Give your answer correct to 3 decimal places. Right, we have already done these. So what I'm going to do is I'm going to use the calculator that's sitting down here. And here is the calculator. Right, if this is the calculator, let's just punch in the figures. What are the figures? Mode, stat. Right, so obviously we do this and we want the a plus bx, so we choose 2. X, where does X start? X starts from 67, 77, and so on. So I'm going to punch in 67. After that, punch in 77. After that, 26. After that, 99. After that, 49. After that, 38. After that, 56. After that, 58. Okay, so we have done the X, and then we are capturing the Y now values. So the Y is 75, then 83, then 32, then 94, then 61, then 44, then 65, then 68. Right, okay, so we have done that. Use your calculator to determine the equation for the line of best fit in the form a plus bx. So to do that, we need to first get the values of the a and the b. So we're going to press on, shift 1. Regression analysis is 5. And we're interested in a, which is 1, equals. Right, you can see that a is 14,533. So we're going to write that one down. So a is exactly 14, that. Right. So let's write that one down. We have a is 14, 533. Then we have b on shift stat 5 regression b2 equals b is 0,863 0,863. Right, b is 0,863. Right, then what is then the equation of the line of best fit? Right, so it follows therefore that the equation of the line of best fit is given by y equals a plus bx, which means y equals, what is a? A is exactly 14,533 plus 0,863 x. So this is the value of, this is the equation for the line of best fit, and we are done with it. Next question. Obviously, you must be able to calculate the correlation coefficient for the data. I know that that one is too easy, so let's just to quickly do that one. So you go to on here. We have already captured the data, so we're going to do shift stat 5 regression analysis. We're interested in R. which is 3 equals, right, you can see that that one is R is actually equal to 0.979. So in other words, R is equal to 0.979, which means R is approximately 1. R is approximately 1. Full screen. Right, so the couple of things that are very important. What does the correlation coefficient suggest about the relationship between the mathematics year mark and the physical science year mark? Obviously, because it is close to 1, it suggests that there is a very strong, strong positive correlation. There is a very strong positive correlation, right? Because the correlation coefficient is approximately 1. Next question. Kaya attained 70 for his mathematics year mark. Use the model in A to predict his physical science year mark. Right, so obviously you can see that the mathematics year mark versus the physical science year marks. So let's look at that carefully. The math year marks are X and the physical science year marks are Y. So which means that we're going to use this equation that says Y is 14,533 plus 0,863 times the mathematics year mark 70. So which means that for Kaya, we're going to say the regression line, which is the line of best fit, is 14,533 plus 0,863 into 70, because Kaya obtained 70 for his mathematics. What then will his physical science mark be? So it's going to be actually 74,9. So in other words, it's going to get about 74,9% in the mathematics year mark. Right, so comment on the accuracy of the prediction in C. Right, so is this prediction of the year mark, because we're just using the mathematics year mark of 70 to predict that in science, if we got 70 according to the line of best fit, is going to get 74,9 in science. But this is not what the mark the student got. But most importantly, let us give a comment on the accuracy of the prediction in C. Is it accurate, this? Okay, so we are speaking about something we call interpolation. Right, so the interpolation usually, right, the interpolation usually results in a fairly reliable prediction. Most importantly, or you can say is the answer on the accuracy of the prediction, the correlation coefficient R is approximately 1, hence strong correlation and reliable prediction, because of the correlation coefficient is approximately 1 means we have a reliable prediction. Next question. In question 2 now, they're giving us this frequency table. We constructed the frequency table in the past exam, right? But in question 2 now, the number of emails received by individual daily over a 50-day period is illustrated in the table like this. Determine the estimated mean. What is the estimated mean? Very straightforward. The estimated mean for this, you can just do quickly, because you need to get half of this to get the estimated mean, and then you multiply by 13. So 0 plus 10 is actually 10. You divide by 2 is 5, and then you multiply by 13 plus 10 plus 20 is 30. You divide by 2, which is 15. You multiply by 21 plus 20 plus 30, which is 50, which is 25 by 12. 30 plus 40, which is 70. You divide by 2, which is 75 times 4. You divide by 30. I said this is 70. You divide by 2, so it's 35. It's going to be 35 this. Right, so you have 15 by 3, by 13, excuse me, 15 by 21, like so 25 by 12, 35 by 4. You divide everything by the total number of this, total frequency. What is the total frequency? So you add this plus this. So if you add this plus this, you get what? You get 34, you get 46, 50. So total frequency is 50. And then if you simplify this, it becomes 16,4. So that is actually the answer there. Right, next question. Right, if you look at this one, represent the data on a cumulative frequency or give. Right, so we have the data that's given, but let's represent it on a cumulative frequency or give. Right, you would see that if you represent the data, let's just look at it very carefully. You have the frequency that is actually sitting at 13. And obviously, when you have to do your or give, you need to extend this and do a cumulative frequency. And then it's going to be 13 here. And you add here, it's going to be 34. You add, it's going to be 46. You add, it's going to be 50. Like so. Like so. Like so. Okay. Okay, now with the cumulative frequency, you start. So at the cumulative frequency 13, you can see that that is between 0 and 10. Okay. So it is actually, you can see that it is just 13, cumulative frequency 13 with 10. Otherwise, then you have 0. So you're going to come here and say, start at the origin. And then if you look at the fact that you have exactly the cumulative frequency on the vertical. So in other words, this is the number of the emails, and you have the cumulative frequency here. Cumulative frequency. And then you are here. Right, so you're going to have a reading, obviously, at the origin of 0. And then at 10, at interval 10, you have 10 goes with 13. So if this here, it's 2, 4, 6, 8, 10. So it's in twos. And then now if it's 13 here, so it's going to be just here 12, 14. So there's going to be like a 13 somewhere there. So which means it's going to be 10 goes with 10, I mean here, goes with 13 on the cumulative side of things. And therefore you have this. Now let's look at the next one, 20. Right, so you can see that 20 goes with cumulative frequency 34, 20, and 34. So 20 goes with 34, 32, 34. So you have this. which is 20 goes with 34. Next, let's just go back quickly. Right, so 30 goes with 46. Right, so 30 goes with 46. 246. So 30 goes with 46. Next. Forty goes with 50. So which means 40 here goes with 50 cumulative frequency. Like so. So 40 goes with 50. Like that. Okay. Now this is the cumulative frequency curve. Like so. This is what they wanted in the June 2023. Just this year, a few months back. So IEB is going to follow this pattern in this coming exam. Do not be surprised to see this paper repeating itself just with different numbers. Right, use your answer in A to, use your answer to A, using your answer to A, excuse me, by determining the median as well. Would you describe the data as positively skewed or negatively skewed? Explain. Let's look at part C. Right, so the median obviously would be seen to lie. Let's look at the median class first. So I shall comment that the median lies in the interval. Right, so the median lies in the interval 10 to 20. So calculated is 15. Or if you don't want to say calculated as 15, or read off the Ogilvy curve. Mean is calculated. Mean is calculated as, right, we got the mean to be 16,4 in A. Since the mean is therefore bigger than the median, because we said the median lies in the interval 10 to 20. So obviously the median is sort of the middle value. So, and it lies, so in other words, if now you look at the median being like your half of this. So if you look at the fact that the total highest frequency at the bottom, the cumulative is 50, and half of that is just at about is 25, right? So, and then now 25 would occur between what? We've already said that 25 is going to occur between 10 and 20. So now, because it's the middle of the highest 50% of the cumulative total, so since the mean is bigger than the median, what would the mean be? Right, the median lies in the interval 10 to 20, so it's calculated as 15. But the mean, we found it in A to be 16,4. If the median is 15, according to the cumulative frequency, we can see that the mean is bigger than the what? The median. The data So in other words, if the mean is bigger than the median, the data is positively skewed. Is positively skewed. Like so. Next question. I'm trying to comment on each question. Let's look at question 3, some bit of trick. Okay, we're going to do some of these. Some of these you're going to participate. I can just give you a chance to comment. Simplify the following. How do you simplify these? Okay, too obvious. What is the first step here, Mara? What formula are we going to use?
I saw the sine 85. That yeah.
Yeah, okay, there's this one here. There's this one that says sine of alpha minus beta. The sine of alpha minus beta is what? Is sine alpha cosine beta minus cosine alpha sine beta. So when you get to this point, you have this one is the sine alpha cosine beta minus cosine alpha sine beta. So in other words, at the end of the day, this is like alpha beta alpha beta. This is like alpha beta alpha beta. So it becomes therefore the sine of the alpha, which is like 85 plus theta. Then you minus beta. Put brackets, please, to make sure you subtract everything here, like so, and then you close. Right, so this is the sine of, what is 85 minus 25?
60.
Well done, 60. And then theta minus theta is 0. What is sine 60, by the way?
So it's cube, yeah.
Okay, I'm just testing you sometimes, you'll forgive me, just to make sure you're engaged. Okay, so here you have 2, the square root of 3, 1, just in case, but yeah, you can use a calculator for this. This is 30 degrees and this is 60 degrees. So we wanted the sine of 60, and we actually could use the SOHCAHTOA method so that the sine of 60 is opposite of hypotenuse, and that is the answer. Let's look at the next question. What is the answer to this? Okay. Right, if you look at this one here, let's simplify it together. So what is this? Right, the tan of minus theta is like minus 10 theta, which is cosine theta. What is sine 2 theta? It
2
is
sine theta cos
sine
theta.
theta, cosine theta, right? And then in which quadrant is the 360 plus? So that, what is this? What is cosine of 360 plus? 360 plus is in the first, where all the functions are positive. Okay, so think of that one. Right. And then this one here is minus. The tangent is sine theta over cosine theta plus 2 sine theta cosine theta divided by cosine theta. And therefore cosine cancels and you have minus sine theta plus 2 sine theta. What is 2 sine theta minus sine theta? It is sine theta. And that's the answer. Anyway, there's a 2 here. So this is minus sine plus sine theta. What is minus sine theta plus sine theta is 0. So the answer becomes 0 there. Okay, just note that. Next question. Right, so if you're given this one, given cosine x equals p and x lies between 0 and 180, express each of the following in terms of p. What is sine x? What is sine x? Right, so this one here, there are a couple of ways to do it, but because you've already been given cosine p, you can use a diagram, but you can always remember that sine squared x plus cosine squared x is 1. So this one is P equals 1. So you want to get sin x, but in which quadrant is 0 to 180 degrees, in which cosine is positive? Because between 0 and 180 degrees, where cosine is positive, it's in quadrant 1, in which all the functions are positive. So here you would see that you have sine squared equals 1 minus p squared. Okay, you can use the diagram here. Ordinarily, this has plus or minus answers. So that this is like sine x is plus or minus the square root. Okay. So if it's plus or minus the square root, then consider what we have here so that the sine of x is equal to what? Is equal to 1 minus p squared, which is positive, okay, in the first quadrant. But you can also use the diagram to do these, okay, because you can just say cosine is positive between 0 and 180, 0 degrees, 90 degrees, 180 degrees. So cosine positive is here. This is the angle x. So this one here, SOHCAHTOA, if cosine x is p, its cosine x is p over 1, so that you have the adjacent over hypotenuse, and this one here is y, according to the Pythagoras theorem, which is 1 minus p squared. So you could say sine x at this point, as said already, this is must be noted just at the bottom of this, so that sine x becomes what? It becomes the opposite over the hypotenuse. So the hypotenuse is 1, so it is exactly this. I mean, you can use the diagram to obtain everything, or you can use the trig identity. Next question. What about cosine 2x? What's cosine 2x? How do you get cosine 2x? What do you think? Right. You can use the fact that the identity here, because this is one is cosine squared x minus 1. That is the most obvious, but you can use others as well. Because cosine x is already there. What is it? Cosine x is p. So this is going to be p squared minus 1. So that you have cosine 2x is that. So cosine 2x is therefore 2p squared minus 1. Next question. Determine the general solution for this. Right, what is the general solution for this? Okay, there are too many ways to do this one, but yeah, we're going to use the easiest one. The easiest one is just to divide both sides by whatever. So it means that we have x minus 30 degrees. So you're going to divide by the cosine of x minus 30 degrees. And this is actually 1 over 2. Tan x minus 30 degrees equals 1/2. What is this? Then you get the reference angle here. Your reference angle is the same as arctan of 1/2, which is 26. So x minus 30, that's 26.6 degrees, plus k times 180. Okay, so the angle is that, and then you move things to the other side. So we need the general solution. So the general solution is going to be exactly this one here. So this is actually 56. If you bring the 30, 56.6 plus k times 180 degrees, k in z. So that's what we're going to get. So this is sort of the general solution. But obviously, the fact that now the tangent is positive and it is what is the guiding factor? How many angles can we get? Positive here and positive there. So if it's positive here, you can see that then the angle is going to be the 26. And then the other one is going to be actually 1/8 plus. So in other words, this solution takes care of both quadrant solutions. And therefore, we can just accept this where k is an element of the set of integers. This is enough for this question. And this is the general solution for 3 marks. Okay, in question 4 in June this year, they looked at, you're given the graphs. We looked at the graphs earlier. Sketch the graphs of f and g on the same set of axes below. Label all intercepts with the axes, turning point and end points. Right. A couple of things you need to consider when you're to sketch the graphs. Let's just get started with sketching the graphs. What do we need to know? Let's start by sketching the graph, the easiest one. Okay, the easiest graph. How do you see the easiest graph? It's a graph that is not translated, okay, because this one is moved 30 degrees to the left. So translated graphs require a lot of focus and attention, but this one is an easy one. It's not translated. It has just an amplitude of 2. So, right, so the sign of 0 is 0. Okay, so you put 90, say 90 is 2. 180 is 0. 270 is -2. 360 is this. 90. So it's 1, 2, 3. 1, 2, 3. 3. So this. Let's see. 1, 1, 2. Okay. 30, 60, 90. Okay, it's in 30s. So you're going to move in 30s here. It's going to be 30 more, which is like 300, 330, 360. 300, 330, 360. Right, so it's going to be like so. Like so. Okay. The next thing is that so this one here is going to be the graph of 90 degrees, x is 90 degrees, and y is 2. Just showing the coordinates. This one is the origin. No one's going to ask. This one is 180 degrees x and y is 0. This one is x equals 270 degrees and y is -2. X is 360 degrees and y is 0 here. Okay, what else? Let me see. Okay, now we need to look at this one. This one is actually a translated graph. Okay, you can use a table for this. You can use a calculator. I'm going to discuss at some point how to use a calculator to sketch the graphs, because you can draw these, you can enter the functions. There's a function component or using mode there. Okay, on the Casio calculator. Okay, but now you can still do without. Because you can just translate the graph. So now one way to do this translated graph is to draw the ordinary cosine graph and then move it by some bits. All right. So what do you do? Right. So the couple of things you need to do. Okay. The easiest one is at the origin. Yeah. When x is 0, you put cosine 0 plus 30. What is 0 plus 30? It's cosine 30. Cosine 30 is the square root of 3 out of 2, which is 0.87. So at 0, it's going to be 0.87. Okay. Then you have 30. Right. There are parts where this graph is going to become 0. So the question becomes, what step do you choose for this? Let's use the same step. The examiner was smart to use the same step of 30 for us, because this one is translated 30 degrees. So the steps of 30 are going to be good enough for us to sort of sketch this graph. Like at 30 degrees, what's going to happen? You put 30 plus 30, which is 60. Cosine 60 is going to be like a half. So it's going to be like so. Right, at 60 degrees, it's going to be 0. Because why at 60? Why is it 0 at 60 degrees when it's 30, 60 degrees? Because cosine 60 plus 30 is 90. Cosine 90 is 0. So yeah, it's the easiest thing to do. But also now at 90, okay, 30. Right, you can look at where it's going to have an intercept. Right, so like here just mark all of them, just to make sure you're right. Okay, at 90 degrees, then it's going to be cosine of 90 plus 30, which is 120, second quadrant. And at 120 is -1/2, minus 0.5. At 120, you add 30, which is 150. Okay, at 150, it is still quadrant 2, negative, which is cosine 150 is the same as 180 minus 30, which is actually minus cosine that. So it's going to be like negative, sort of. And then let's see it. Okay, this is like 120. At 150, it's going to be exactly here. Because at 150, 150 plus 30, it's x plus 30, this function. X plus 30. So 150 plus 30 is going to be like 180. Okay. Cosine 180 is the easiest, is minus 1, so it's a whole number. Very good. So this one is going to be there at 150 degrees is going to be minus 1. And then here, and then what about at 180 plus 30? It's going to be a negative something, but so. And then at here, it's going to be like 210 plus 240. This one, it's 210, then 240. It's going to be 240 plus 30, 270. Cosine of 270 is a big 0. So this one is very important. It's going to be a 240 and it's going to become 0. At 360, is going to be a big 1. Okay, look. At 330, at 270 it's going to be like 300. They're still rising. At 300. At 300 it's going to be 330. At 3, this is 300, 330. At 330 is going to be 330 plus that. It's going to be exactly here. At 330. So in other words, at 330, when x is 330, it's 330 plus 30, which is what? Which is a big 1. Right, so it's going to be like here. At 360 plus 30, 390. Can I go down a little bit? So this one is G. So we have this. That's the answer. And these are the graphs here for the G function and the F function. Okay, the F is this. Next question. Show that the graph of G can be written in the form this. So that's obvious. You'd remember that the graph of G of X is actually the same as what? It is cosine of X plus 30. Okay, X plus 30. Check again. Yep, X plus 30. X plus 30. So this one uses X plus 30, so is cosine of alpha plus beta. This is the formula, which is actually cosine alpha, cosine beta, and then it is minus sine alpha, sine beta. So for the cosine is plus, then it becomes minus. In which case here, you're going to have cosine x, cosine 30. Minus sine x, sine 30. So which is 3 out of 2 cosine x, which is 1/2 sine x. So if you look at the common factor here, the common factor is just 1/2. Pulling 1/2 out leaves us with the square root of 3 within the parentheses, cosine x minus sine x. This is how that one will be done. Indicate clearly on your graph the values of x for which this is going to be the case. Okay, so you need to analyze this here and what is happening on the graph and what the question is going to be there. If you indicate clearly on your graph where you're going to have this, what is happening here? So obviously you can divide through by 2 here. If you divide through by 2, you have 4 sine x, which is the square root of 3 cosine x minus sine x. You divide by 2, which means 2 sine x, which means 1/2 into the square root of 3 cosine x minus sine x. So this one here is f of x equals g of x. So it's where the two functions are equal. Indicate on your graph where the values can be found. So they are on the graph. We need to indicate on the graph. The graph has been drawn. So would indicate like here where they're equal to each other. And also you would indicate at another point where they are equal to each other because they are equal at this point as well. So now they're equal at this point where they intersect. There is point A, but here where they intersect, there is point B, like so. Okay, and you have exactly that. Next question. Right, we've shown that. Next question. In the diagram, AB is the diameter of the circle with center O. So you've been told that AB is the diameter. What angle does it subtend this? Because the diameter, it must subtend an angle of 90 degrees at circumference, but also if it is a diameter, it must subtend a couple of angles. D and E are points on the circle so that DO is parallel to EB. DO is parallel to EB. C is a point on the circle as shown. C is a point on the circle as shown. O1 is 40 degrees. Okay, O1, this one, is 40 degrees, like so. Right, state all relevant reasons with your statements. Determine angle A1 for 2 marks. What is angle A1? Right, this is too obvious. What is angle A1? Your thoughts? Okay, so this one is the center of the circle. So this one is like a radius, and this is like a radius. So this triangle here is isosceles. So it means therefore this angle is 40. This angle must be equal to this. Okay. So in other words, what then is the answer? Right. So which means that angle A1 is actually angle A1 is equal to angle ADO. Angle A1 is equal to ADO. Why? Right, A1 is equal to ADO. Why? Because OA is equal to OD radii. OA is OD. OA is OD radii. So which means that we can get angle A1. Angle A1 would have to be 180 degrees minus 40. And then you divide by 2. And this has to do with the interior angles of triangle. So angle A1 is the same as 180 minus 40, which is what? Which is exactly 140 divided by 2 is 70 degrees. So it is 70 degrees. There's a way to check that. You can say if this one is 70 degrees, 70 plus 70 is 140 plus 40 is 180 in this triangle. So we sorted. What about the size of angle E? Determine the size of angle E. What is angle E? This one. It's obvious, right? So what do we say? Obviously, we're dealing with a cyclic quad here. This vertex cyclic quad. So what? This is a straight line, this, so we sort it. Goodness me. So obviously, if you know that this one is already 70 degrees, this plus that, this must be 180 degrees. So this can only be 100 and what? And 10 degrees, because 110 plus 70 is 180. So that would be angle E is 110 degrees. Why? Because these are opposite angles of cyclic quad. Opposite angles of cyclic quad. Next question. Determine C1. Okay, if you look at angle C1, what is the size of angle C1? Angle C1 is this one. What is the size of the angle C1? Right, so obviously a couple of ways so to find the angle C1. Right, what would we say the size of angle C1 is at this point? Right, so it's the angle at center theorem that we can use here, because you can see that at this point, you know very well that this angle here is actually exactly 90 degrees. But you know that angle C1, angle O1 is twice C1. Just see that. Angle O1 is twice C1. Excuse me. Angle O1 is twice C1. Why? Angle at center equals to 2 times angle at circumference. So what is angle O1? O1 is 40. Right, angle O1 is 40 twice C1. Why is angle O1 40? O1 is 40 degrees. Why? Given. So angle C1 is 20 degrees. Angle C1 is 20 degrees. What is the size of angle B1? So normally you must plug everything you get there. So this one is like 20 degrees. What is the size of angle B1? This one. Right, the size of angle B1. Okay, these are clearly corresponding angles. You can use co-interior angles, etc. So if this is the angles in F from grade 10, is the fun word. So this is part of this. So this angle is equal to this. So which means that this is also 40 degrees. So B1 equals 40 degrees, the corresponding angles. B1 is equal to 40 degrees. These are actually corresponding angles because DO is parallel to EB. DO is parallel to EB. Right, if AE is constructed and intersects DO at F, determine the length of AE if the diameter of the circle is 9 units. If AE is constructed and intersects DO at F, AE is constructed. Right, so if AE is constructed and intersects like so, and intersects DO at F, determine and intersects DO at F, determine the length of AE if the diameter of the circle is 9 units. If the diameter of the circle is 9 units. Right. Good. So we need to find the length of AE. Right, if the diameter of the circle is 9 units. You need to just find the length of AE. If the diameter of the circle, in other words, the distance from here to there is 9. You need to find the length of A. Okay, it's just similarity and proportional to this one. So, but first and foremost, you have that AF is equal to FE, which is a line from midpoint parallel to one side of a triangle. AF equals FE, line from midpoint parallel to one side, line from midpoint parallel to one side of triangle. And that therefore means, okay, we're gonna check that, but yeah, it means therefore DO is perpendicular to AE. It therefore means DO, it would mean therefore DO is perpendicular to AE, meaning this angle is going to be a right angle here. DO is perpendicular to AE. Why? Because of the line from center to midpoint of chord. Line from center to midpoint of chord. Right, so this one is going to be line from center to midpoint of chord. Now, moreover, we have something to mention in triangle AOF. In triangle AOF, we can find sine 40 because this angle is 90 degrees. So we can find sine 40, which is AF over 4.5, because now we are dealing with the fact that the radius is actually 9, so you can divide that one by 2. So if you divide 9 by 2, it becomes 4.5, which means the sine of 40 is AF over 4.5. The sine of 40 degrees, which is AF over 4.5. AF is approximately 2.9 units. Okay, you have that FE is 2.9. So you have that FE, you have that AF. AF is approximately 2,9 units. If AF is approximately 2,9 units, then that means that AE is double AF. AE is double 2,9. So AE is 2 times AF, 2 times that. 5,8 units. Like that. So question 6, in the diagram, AC is the diameter of the circle with center O. So we have that AC is the diameter of the circle with center O. B is a point on the circle. Okay, B is a point on the circle, and AB is produced to D. AB is produced to D, so that DC is a tangent to the circle at C. Right, AB is 5 units. Right, you have that AB is actually 5 units. And we have BD is 4 units. You have BD is 4 units. You have that C2 is X, like so. And now determine, and you have that B is produced, that DC is a tangent to the second at C. So this one is a tangent. Determine angle A in terms of X. Determine angle A in terms of X. But obviously, since this one is a tangent from the ten-chord theorem, we know A equals X, the ten-chord theorem. Okay? A equals X, the ten-chord theorem. So ten-chord means this angle equals this angle equals that. Good, we are sorted. So next. Prove that triangle CBD is similar to triangle ACD. Right, prove that triangle CBD is similar to triangle ACD. CBD, but yeah, you have that D is a common angle, but the angle B2 is actually equal to 90 degrees because this one is a diameter, so it subtends an angle of 90 degrees at circumference. So if one is diameter, it subtends an angle of 90 degrees at circumference, so that angle B1 is 90 degrees, but most importantly, angle B2 is 90 degrees. These are adjacent angles on a straight line, B2. So we're going to be working, Mr. Examiner. Yes, hello, my dear. No, I'm okay, my dear. Yeah, thanks, my dear. CBD and triangle ACD. B2 equals 90 degrees. And these are exactly the adjacent angles on straight line. Okay, like we saw. And then now we have also that this B2 is going to become 90 degrees. Adjacent angles on a straight line there. But also it is clear that angle ACD is equal to 90 degrees as well, because it's a tangent perpendicular to a diameter. So ACD is equal to 90 degrees. tangent perpendicular to a radius, which means angle C2 which means that angle C2 is actually equal to angle A, technical theorem. C2 is equal to angle A, and this is the 10 chord theorem. 10 chord theorem. Moreover, we have that angle D is common. So therefore, triangle CBD, which is similar to triangle A to triangle ACD. Why? Because of angle, angle, angle. Like so. So you have exactly this. You have exactly this. Next. Right, determine the length of CD. Determine the length of CD. To determine the length of CD, you need to say since the triangle CBD is similar to triangle ACD. And this actually, why? Because it has been proved, in B above. So you have CB divided by AC, CB divided by AC, which is BD divided by CD, which is, so CB divided by AC, which is BD divided by CD, which is CD divided by AD, okay? So you always take the first, with the first CB over AC, then you take the second, with the second BD over that, and then you take the last. Okay, you proceed therefore to look at what is going to give you CD. So you can see that CD occurs in two places, CD, CD here. So which means that you're going to take BD over CD. We're going to take BD over CD is equal to CD over AD. And obviously, now you can cross multiply this, which means that BD over AD, which is CD squared, which is BD. Right, so BD is 4 units and AB is 5 units. BD is 4 units and yeah, BD is 4. You can see that BD is 4. What about AD? AD is 9. AD is 5 plus 4, 9. So AD is exactly 9. CD squared. Which means, therefore, you have the square root of 4 by 9, which is the square root of CD squared. which is CD, plus this one is 6 units. CD is 6 units. So now let's look at this one. Question 7, diagram AC is the diameter of the circle with center O, BD is the chord of the circle. And we have that B1. B1 is actually 67.5 degrees. And we have that C1 is 45 degrees. Is triangle ABC isosceles? Is triangle ABC isosceles or not? Okay, but what we can see clearly, because O is the center of the circle, so this one is going to be an angle of 90 degrees, but also this one is going to be an angle of 90 degrees. This one is obviously a cyclic chord and so on. But we can see clearly from what I've just marked now that angle B is equal to 90 degrees, which is an angle in semicircle. C1 is equal to 45 degrees. Why is C1 45 degrees? It has been given. Right. So what is angle A1? Angle A1, therefore, is 180 degrees minus 90 degrees plus 45 degrees. So, yeah, is A1 is 90 minus, is 180 minus 90 to 45. So this is true because of the interior angles of triangle. And therefore, it means, therefore, at this point that angle A1, what is this? Angle A1, therefore, is equal to 45 degrees. Isosceles triangle, which is sides opposite equals angles. Right. So we have, therefore, obviously what we're effectively saying here is that angle A is 45 degrees. A1 is 45 degrees. Isosceles triangle, so A1 is 45 degrees, so that the triangle ABC is isosceles, because we have seen that this one is also 45 degrees. So isosceles means the triangle ABC has two adjacent sides equal to each other. Next question. B2. B2. What is B2? Okay, what is this one? This one is A1 equals 2 times A2. Prove this. Right, to prove this, we start as follows. We can see that, let's find first angle B2. What is the size of angle B2? B2 is going to be 90 degrees minus 67.5. So angle B2 is 90 degrees minus 67.5. Angle in semicircle. Angle in semicircle, which means B2 is 22.5 degrees. A2. What is A2? Okay, angle A2 is going to become what? Okay, because this one is also angle A2 is going to become what? A2 is going to become actually angle in the same segment. A2 is B2. A2 is B2, the angles in the same segment. So which means that A2 is going to become also B2, and therefore A2 is going to also become 22,5. So A2 is equal to B2, which is 22,5. Why is A2 equals 22,5? It is angles in the same segment. Angle A1. What is angle A1? Angle A1 is 45 degrees. So angle A1 is 45 degrees. Why? It has been shown above or proven above, or it has been proved. Proven above. Okay. So what do we need here? Okay. And then it is clear, therefore, that the angle A1 is 2 times angle A2. Because angle A1 is 45 degrees and A2 is 22,5. So if you take 22,5, you multiply it by 2, it's going to become 45 degrees. So which means that 45 degrees is 2 times 22,5. So A1 is 2 times A2. So we've proven the fact that angle A1 is 2 times angle A2. Next. Right, the next thing is we need to prove this result here. Section B is about proving more circle geometry. Use the diagram below to prove the theorem that states that the line drawn from the center of a circle perpendicular to a chord bisects the chord. Here it is, the line drawn from the center of a circle perpendicular to a chord bisects the chord. So we have this. So now at this point you can join AO and OB. So join AO and BO. So in the proof, you're going to start by saying you're going to, Mr. Examiner, you're going to work in triangle AOC, triangle AOC, and triangle BOC. And then you have OC, OC is a common side. So if OC is a common side, AO is actually equal to OB. AO equals OB. Why? Because these are radii. So you have that AO equals OB, which are radii. C1 equals C2. Angle C1 is equal to C2 equals 90 degrees. These have been given. So they've been given that C1, C2 they're both 90 degrees each, or they're 90 degrees each. Right, and now we have 3 facts about this. And thus we can be able to make a conclusion about, you need just 3 cases, and therefore the triangle AOC is congruent to triangle BOC. And then this is right angle, hypotenuse, and a side, and hence And hence, because these two triangles are congruent, the AOC and BOC, therefore means that AC equals CB. Hence, AC equals CB. And we have proven that AC equals CB given this diagram. AC equals CB given this diagram here. So we continue. Right, in the diagram, we have that O is the center of the circle, but also chord AB is 8 units. Chord AB is 8 units. So you have that this one here is 8 units. The perpendicular distance from the furthest point on the circle to chord AB is 8 units. The perpendicular distance from the furthest point on the circle to chord AB is 8 units. Okay, there it is. Determine the radius of the circle with center O. What is the radius of this circle? Let's get started with this one. Okay, we just given this situation, and what is the radius? The distance from the center to the circumference, what is it? Right. So after at this point, what you need to do, you need to do a construction. So you need to draw let line perpendicular to AB meet AB at M. Line perpendicular to AB. Line perpendicular to AB meet AB at M. Line perpendicular AB meet AB at, you can call this one M, like so. Call it M like that, or just M like that. CM goes through the center. So you have CM goes through the center. BM equals MA. So you have that BM equals MA. So here you can clearly see that CM goes through the center. BM is equal to MA is equal to 4 units. BM is equal to MA is equal to 4 units. So this is 4 units. Like so.
So how are they 4 units? OB and OA?
Please come again.
How is OB and OA 4 units? Isn't it
Yeah, how is OB
MA and AB?
Just a minute. That's not what I want to say. I want to say BM is equal to MA is equal to 4 units. Yeah, that's what I wrote actually. So it's BM equals MA equals 4 units because we need to find the radius here. So BM, so in other words, this one is 4. This one is also 4. BM equals MA equals 4 units. All right. Okay, we want to find the radius. Why? Why are BM equals, why are they 4 this? Because you already know that AB is 8. AB is 8. So we cut 8 into 4 units. Why 4 units? Why is BM equals MA equals 4 units? Because of the line from center. Because of the line from center perpendicular to chord. Like so. Okay, because this line is from center and perpendicular to chord, it bisects the chord. In triangle AOM, okay, I want us to consider triangle AOM. Okay, in triangle AOM, this one here, I want us to let OM be equal to X. I want us to let OM, this one, O to M, we call it X. Okay, you know, this is untidy, but yeah. I want us to let OM be X units. Right, what is then the radius of the circle here? Okay, because you already know that the distance from the chord to C is 8 units. So that will mean that CO is 8 minus X, because it's the whole thing is 8, but you're removing X, so it is this one here. 8 minus X. So that means the radius which we actually mostly need for this question. Therefore, the radius CO is equal to 8 minus X. Okay. Right. So yeah, we need the radius. We're getting closer to it because we got 8 minus X. We just need to use algebra. And once we get to this point, if the radius is that, it means that we can use that fact. So we can use the fact here that the radius is 8 minus X, but also here the radius is also 8 minus X. Like that. So we then have a triangle. We can take one of these triangles. So we can take like this one. So you have O here, this O, and then this one we called it X, and then we have 4, then we have 8 minus X. This angle is right. It's a right angle triangle, perpendicular, and this is M, and that is exactly A. Okay, with that said, we are well set. We can just use Pythagoras theorem from here. So we can then say 8 minus X squared is equal to 8 minus X squared is equal to X squared plus 4 squared. Why? Why is 8 minus X squared equals X squared plus 4 squared? It is Pythagoras. So, right, we do the algebra and you get that 16x is equal to 48 out of this. You divide 48 by 2, you get that x is 3. And if x is 3, what is the radius? The radius is, so the radius is 8 minus 3, which is 5 units. Five units. Right, so the radius is actually 5 units. The radius is 5 units, so which is 8 minus 3, which is 5 units. Next question. Let's do some similarity and proportionality. Like in the diagram, ABC is drawn, triangle. ABC is drawn, but also E and F are points on AC. Okay, let's look. E and F are points on AC and AB respectively, such that AE over EC, let's check. AE over EC is 3 out of 2. Okay, let's mark this one. so that you cannot forget. AE over EC in the exam, normally you need to mark AE over EC is 3 out of 2. And then now there's AF over FB. So AF to FB 5, like so. Right, BC, BC produced meets FE produced in D. Where is BC? BC produced meets FE produced in D. G is a point on FB. G is a point. G is a point. On FB. On FB, there's a point G. So that FD is parallel to GC. FD is parallel to GC. FD is parallel to GC. Okay, they've been shown to be parallel. Calculate giving reasons, this one, calculate giving reasons, BC, the ratio of BC to CD. Let's look at this one. Let's look at these exactly. The ratio of BC to CD. Okay, first things first, we are going to work in triangle ACG. So in triangle ACG, you have AE over EC. AE over EC is equal to AF over FG. Why? Because of the line parallel one side of triangle. Right, so with that said now, this is what we have. But what is AEEC, which is 3PEC, it's 2P, which is equal to, what is AF? AF is, you can call this 2K. 2K out of FG. So which means therefore that which is 4 over 3, like this. So which means that in triangle BFD, BG over, let's look at BFD. Let's look at triangle BFD. Right. We can take BG over GF to be equal to BC over CD. You saw it? So it's BG over GF, and this is equal to BC over CD, which is what they want here. Why is this the case? Because of the line parallel one side of triangle. So this is 4 over 3, K, which is BC over CD. Okay, you can be able to see that at this point, what is GF or FG is 4 out of 3, K, but what is BG, right? So if you look very carefully, your BG is actually the same as 11 out of 3. It is exactly 11 out of 3. Okay, you can be able to show that, can easily show that the BG is 11 out of 3 because of the parallel lines there. Okay, parallel lines FD and GC. What is the meaning of these at the end of the day? So these would therefore mean that BC over CD is actually the same as 11 out of 4. So check this because that's what they asked us to do. They said determine BC over CD, and BC over CD, it's therefore 11 out of 4. So now if you look at your BG part, so there are a couple of things obviously you can always consider at this point. And it is most certainly that you can be in a position to use the ratios we know, right? For example, what would any of these be? If you use exactly these and you use exactly that, like 3 out of 2, and this one is 2 out of what? If this is parallel to this, what do you get? Right, if this is parallel to this, 2 out of 3, so what would AF over FG be? So we've seen that AF over FG becomes AE over EC, and therefore that gave us FG to be this. Right, so if you have FG, what is FG? I want to just give a comment here. Right, so you have FG. What is FG? Is this one? 4 out of 3K. 4 out of 3. 4 out of 3K. That is FG. Okay, we are using K for this side, but we chose P for the other side. It's fair. Okay, right. So if you need, therefore, obviously, just to give a concurrent comment on the BG part, right. So if this is actually FG, then what would BG be? Right. So in other words, you are using the K method here. Right. So if you're using the K method, you're going to consider a couple of things, obviously. Right. You're going to consider the fact that this one is 5. So you can use the fact that you can call it 5K. We're using lots of Ks here. So I'm commenting on that so that it can be very obvious why we chose BG to be this just in a second. So BG is going to become what? So BG is going to be, I'm sure you can see that. So BG is like BF. Just write obvious step. It's BF minus FG. Minus FG. So which means BG becomes BF. What is BF? 5K. And this one is 4 out of 3K. What is 3 by 5? 15 minus 4K out of 3. BG will be the same as 11K out of 3. And that is why we use the thing. Just a comment. But most importantly, then we have got that here we're using the P's. This side. Like that's why we used 3P and over 2P. But now calculate giving regions the BC over CD. So we got that BC over CD is 11 out of 4. Can you move to the next question, please? Right, I want us to move to look at question 10. And now if f is a single trigonometric function and you have this, determine the constant a and the trigonometric ratio f of theta. Right, f is a single trigonometric function. And you have this, determine the constant a and the trigonometric function f of theta. So which means that at this point you'd have sine theta times cosine 2 theta, which is divided by, which is this? Right, it is divided by exactly this, but sine 2 theta is the same as 2 sine theta cosine theta. And division sign from the examiner, the tangent is the same as sine theta over cosine theta. Okay, the tan is sine over cosine, but it's 1 over, so it becomes cosine over sine theta. What is this? This is exactly the sine of theta cosine 2 theta divided by 2 sine theta cosine theta division. This one times this, which is sine squared, minus cosine squared theta divided by sine theta cosine theta, which is the same as what? Sine theta times cosine 2 theta divided by 2 sine theta cosine theta multiplied by this one. You can change it to times, this division. So if you change it to times, then it becomes the multiplication, it becomes sine theta cosine theta divided by, okay, this one you can just take out a negative, and then it is sine squared theta. What is cosine 2 theta? It's cosine squared theta minus sine squared theta. Okay, what's the answer? Okay. This one is the sine theta cosine 2 theta divided by, so this one is 2 sine theta cosine theta multiplied by the sine of theta cosine 2 theta. Which means a f of theta. Okay. Now this cosine 2 cancels cosine 2. This one cancels this. What are we left with here? We're left with minus 1 over 2 sine theta. Minus 1 over 2 sine theta. So, okay, this is what you have. Right, so what is then the question? The question has been determine the constant A and the trigonometric function f of theta. Right, so if f is a single geometric function, what would the value of A be? What would the value of A be? Ideally, I mean, what is very evident from these, if f is a single function of theta, you can relate to the fact that A itself becomes a coefficient, and you can write in that manner. Meaning you can relate that A is potentially the minus half, and the f of theta is sine theta. So that the product is this. This would be one possible solution to the problem. Right, because we determine the constant A and the geometric function f of theta. And f of theta is a sine where A is that. So yeah. Next question. Determine the values of theta for which the identity is not defined. Right. Identity not defined. Okay, the identity is not defined when the denominator itself becomes 0. So there are two instances when that is happening. So in the three instances when that is going to be happening. Okay, so first instance, it's going to be when tan theta is 0. So you're going to have tan theta is 0. And because it's in the denominator, so that it is going to be undefined. But also when you have the sine 2 theta equals 0.
Sir?
When you have the sine of 2 theta equals 0. And also this denominator, because it's this divided by this, it's when this whole denominator is 0. So it's when you have tan theta minus 1 over tan theta. Tan theta minus 1 over tan theta is equal to 0. And when is the tangent equal to 0? When is the tangent undefined? Okay. So, I mean, one can look at a case where the tangent itself is undefined as well, because the tangent is a fraction. Okay, let's look at where the tangent is undefined. The tangent undefined means that the tangent is sine over cosine theta, and you're looking at where the cosine theta is 0. And that is going to be for theta, if you use arc cosine, 90 degrees and 270 degrees. When is the sine 2 theta equals 0? Right, you can do reference angles and other things. But the sine equals 0 when you have 2 theta being arc sine 0, and arc sine 0 is what? It's 0 degrees. So, and that would mean that it's 0, but also you have other angles like 180 degrees there. Okay, sine 2 theta equals 0. Like here. So if you divide by 2, it would mean theta is 0 divided by 2, 90 degrees. You divide 360 by 2, you get 180 degrees. Theta, which is 0 degrees, it's 0 degrees, but also when you have 90 degrees, because 2 times 90. But also when theta is 90, because 2 times 90 is 180. Sin 180 is 0. If you put to check here, 2 times 0 is 0. Sin 0 is 0. So you have 180. 2 times 180 is what? 2 times 180 is 360. So also 180 degrees. Okay, we're looking at between those angles between these. but also when we have 360. Right, because yeah, we have that. Okay, when is this one undefined? This one will be undefined at a couple of things. Right, or when will these become 0? Right, you need to solve just this equation straight away to find out the values of theta. So you can just transpose and manipulate 1 over the tangent of theta. You cross multiply, which means 10 squared theta is 1, and you take the square roots. That would mean 10 theta is plus or minus 1 if you take the square root here, and put plus or minus. So when is the tangent plus or minus 1? So you have 45 degrees, which is 1, 135 degrees. Okay, at 135 degrees, it's the second quadrant where the 10 is negative, so you're going to have a minus 1. But 225 degrees is in the third quadrant where the 10 is going to be 1. 315 degrees is in the fourth quadrant where the tangent is going to become minus 1. So you have the alternation of the signs there. So determine the values of theta for which the identity is not valid. So these are the values of theta there, and we're done with that question. But you need to note that where theta itself, theta lies, okay, it's in the closed interval, square parenthesis, 0 degrees to 360 degrees. Okay, so square parenthesis, like so. Next question. Write in the diagram below, ADC represents a horizontal field. ADC, a horizontal field, triangular field. Right, you have that BD represents a vertical building. BD is a vertical building standing on ADC, standing on the field ADC. And now we have AC is 120 meters. AC is 120 meters, so we have this one is 120. DAC is alpha. ACD is beta. The angle of elevation of B from A is theta. Very important. The angle of elevation of B from A is theta. The angle of elevation of B from A is theta. Here. Okay, what do they want us to prove here? Determine the height of the building in terms of alpha, beta, and theta. Simplify your answer. See that one. So very easy. Now we're going to first have to find this angle ADC. Triangle ADC is 180 degrees minus into alpha plus beta. The interior angles of triangle. Interior angles of triangle are involved here. So which means that this angle we know already, ADC. And what we want to get, we want to actually get BD. So now BD can be obtained in terms of theta because BD is actually opposite of adjacent. So we have that the tan, yeah, anyway, in triangle, this is in triangle ADC, like so. So that, okay, doesn't matter what we do. Right, in this triangle, then we can be able to get this 120 here. So we're going to say 120 over the sine of the angle opposite, which is the trigonometric sine of this angle ADC. It is 180 degrees minus alpha plus beta, which is AD over the sine of beta. So you have 180 minus, which is in the second quadrant, in which is the sine of alpha plus beta. Right, so next we're going to work in triangle ABD. So the tan of theta is opposite over adjacent, which is BD over, tan of theta is BD over AD. Is BD over AD. Which means it is AD tan theta. Which means you have BD. What is AD out of this? AD is this. So here we put AD, which is this, 120. The sine of beta divided by, okay, times tan theta. I'm just putting this. And then now the bottom is the sine of alpha plus beta. So you can write the sine of alpha plus beta. I mean, this is not the only way you can write the answer like this, or you can write that BD is 120. Sine of alpha, cosine beta plus cosine beta, sine alpha. Let's do it, question 11. Right in the
Sir?
diagram. Yeah, you're fine?
Sir, I had a question for question 10A1.
Okay, let me see.
So the bottom part there where it's AF, the function of AF. So how did we get from there to there?
Like, how did you move from here to here?
No, so the bottom part there of
This
the
one.
function. Yes, sir.
Okay, I'm not sure if I understand which one are you saying. How did we get f of theta equals sine theta?
Yes, sir.
All right, we got it from the fact that at this point we have the given information. What is the examiner saying? F is a single trigonometric function. And you have this. Determine the constant A. So we must find the constant A and the trigonometric function f of theta. So after we got to this point, after we got here, right, it is clear therefore that we actually have to use the fact that f is a single function of theta. So, and is these times f of theta. So one possible value of A is 1/2. So it is possible to say A is minus 1/2 and f of theta is sine theta. Because when you multiply the A and the f, you get minus 1/2 sine theta. So
Thank you, sir.
yeah, so that is just one possibility. But yeah, there are multiple other possibilities. So this was not a very good question from the examiner. It really could potentially have multiple solutions at the end of the day. Right, so next, okay, we have this. Right, if you look at question 11, in the diagram, you have triangle ABC is drawn with A equals -2 -1 and B equals that. Right, A equals -2 -1 and B equals has coordinates those. D has coordinates -4, 5 is the center of the circle. ADC cuts the circle at F. ADC cuts the circle at what? At F. With AF equals FD. AF equals FD. E is a point on the circle so that CE is a tangent. E is a point on the circle so that CE is a tangent to the circle at E. Okay, so this CE is a tangent. BC is perpendicular to AB. BC is perpendicular to AB. Right. So if BC is perpendicular to AB, let's see where's BC, where BC is. Right. Here's BC is perpendicular to AB. Determine the equation of the circle with center D. Right. Determine the equation of the circle with center D. Right. Let's check that one. Right. So at this point, you can actually be in a position to find the answer to this, which means the center is D with coordinates that. D has the coordinates -4 and 5. So, well, at this point, this would be x minus into -4. You square this, y -5. Minus, so you always minus this, you minus this, you square this equals to radius squared. So that will be sort of the formula that we can determine. But now we actually need to find the radius. For us to find the radius, we can find the coordinates of the point F, because F is like the midpoint. Okay, so we have so we have F, which is XFYF. So, okay, this F is the midpoint. So what are the coordinates of F? You can use the fact that the coordinates of F would be x1 plus x2 out of 2, and this would be y1 plus y2 out of 2. So this one is x1, y1, this is x2, y2, or vice versa. What is x1? It would be -4 plus x2 is -2 out of 2. Y1 would be 5 and y2 -1 out of 2. What is -4 minus that is -6 divided, which is -3? 2. Right. So it means that we found the coordinates of F, and we just need to get the radius of this circle, the distance from here to there. Okay, obviously there are a couple of ways to find the radius. We can just use, take a point on the boundary of the circle, and we can take the point F. Putting the point F into the equation of the circle, we shall have the following, that x is -3, minus into -4, y is 2 minus 5, is radius squared. So you can just substitute the point F into the equation of the circle to get what is required. And this is r squared equals 10. Okay, because if you have -3 plus 4 is like a 1. So it's a 1 plus, this is a 9, giving a 10. And what is the equation of the circle? It is actually x plus 4. You square these, and then y minus 5. You square these, which is equal to 10. So we have this. What are the coordinates of C? Right, C is a point that's sitting outside there. And what are its coordinates if the tangent is given there and you have the rest of this information, and this is perpendicular and so on and so forth. What are the coordinates of C? There are many ways to find the coordinates of C, so let's find the gradient first. Let's find the gradient of AB. Right. Quickly, the gradient of AB is change in y, change in x. Y2 minus y1, x2 minus x1. Which is minus 10, 3, minus 2, minus 1. Minus 10, 3, which is B? Which is B? Which is x1, y1, x2, y2. Y2 is 3 minus y1. X2 is minus 10 minus x1. And this is 4 divided by what? Minus 8. Yeah. And this is minus 1/2. So the gradient of BC, like C somewhere there, and the angle is 90 degrees. So the gradient of BC must be 2. So you invert this and multiply by the negative because they're perpendicular lines. The reason for this is that the gradient of AB times the gradient of BC is -1. Why? Because AB is sort of perpendicular to BC. And this perpendicularity was just given by the examiner. So yeah. Okay. Right. This here would be now we want to find the equation. So the equation, we have the gradient, it passes through that, so we can use y minus y1. We want to find the equation of the line BC, but we know one point there. The point B through which line BC passes, so this is x minus x1. But this line BC, actually, we agree that from the sketch and from the diagram given in the exam, it actually passes through B with the coordinates minus 10, 3, which is x1, y1, which means y minus 3 equals the gradient 2 into x minus 10, which is 2x, and this is plus 20 plus 3. Okay, and then what is this? It is y equals 2x plus like 23. Okay, and this gives us the equation of the line AC. Y equals 2x plus 23. But now I want to find the coordinates of C, so it's a point of intersection. We can find the equation of the other line that's like AC, or yeah. So what is the gradient of the line AC? Right, to find the gradient of the line AC, we can use any of the points on the line AC, like we have A and D, so we're good. A has the coordinates -2, 1. D has the coordinates -4, 5. So you have the point D here with the coordinates -4, 5. Okay, if you look at the the gradient of AC is y2 minus y1 over x2 minus x1. That is the gradient of AC. Right, so this will be like x2, y2. What is y2? Y2 is going to be like 5. Y1 is minus 1. Goodness me. X2 is minus 4. X1 is minus 2. And the answer is what? Is 6 out of minus 2. And this is minus 3. Okay. Effectively, what we're saying here is that the gradient of the line AC, is minus 3. Okay. If it is minus 3, then you can find the equation of the line AC by using any of the points A or D. So let's choose point A through A with the coordinates minus 2, minus 1. Right, we agree that we have y minus y1, which is m into x minus x1, so which means y minus x1 y1, which is minus 1 into the slope of the line or the gradient, and x minus x1, which is minus 2, like so. Right, simplifying everything here, this is going to be minus 3x, and this is going to be actually minus 6, and you subtract 1, and that is minus 7. For C, point of intersection, we have minus 3x, which is 2x plus 3. Which means if x is minus 6, then y is equal to 11.
Sir,
Yes?
can I quickly see the diagram?
Okay. Right.
Thank you,
It
sir.
looks like this, but we want to find the coordinates of C.
Sir, so how is C the point of intersection? It's the point of intersection for which two?
Yes, okay, that's a good question. How is it dependent of intersection? The equation of the line BC. Okay, the equation of the line BC, we found it to be 2x plus 23. And then now we also found, so the equation of this line, and then we also found the equation of this line, which is the equation of the line AC. We found the equation of the line AC to be y equals minus 3x minus 3x minus 7. So these two lines intersect at C. Want to find the coordinates of C because the two lines intersect? There's not quite a very obvious way to find the coordinates of C except to use the equations of the two lines that intersect at C. So we're going to have a very correct answer, no doubt. These two lines surely intersect at E, so at C. So to find the coordinates of C, we just need to solve these two equations simultaneously. Okay. So that is what, so we just equated them. We just equated the two equations. So this is 2x plus 23, please. Because we agree that the equation of the other line is 2x plus 23, and you equate them, and you get x equals to minus 6, and then y equals 11. By substituting the x value into this, like if you substitute minus 6 here, it becomes minus 6 times minus 3 times minus 6, which is 18. 18 minus 7 is actually 11. What are then the coordinates of the point C? It is actually minus 6 and 11. I must indicate that obviously there are a couple of ways to solve this question. It's not just this way only to solve the problem, but this is the most correct. The most correct. Any method will have to yield this answer. Next question. Right, we have the diagram that has been given. Determine the length of the tangent CE. Determine the length of the tangent CE if it is given that the coordinates of C is this. Okay, they want the length of the tangent CE. Right, they want the length of this one. If they've given that the coordinates, okay, you see they've given us the coordinates of C, they are, because the examiner knew that we need to use them. Now they're giving us, and we got them to be -6 and 11. So the -6 and 11 are correct. So the examiner obviously was afraid that if they do not give the answer, it's going to be unfair to the student who could not get the answer, the coordinates of C to be -6 and 11. And then now we need to find the length of CE. Let's find the length of CE. Where do we start? So we're going to work in triangle CDE. So we're going to say in triangle CDE. Right, so if I do this and work in this triangle CDE, it is clear that if this one was said to be tangent in the question, so that tangent is perpendicular to radius, because this is the center. From the center to the circumference, we have a radius. So which means that DE which is tangent perpendicular to radius. What is DE? What is DE, the radius of this? Okay, obviously you know a couple of things, like this distance is equal to this distance. We've already found some distances, like what distance did we get? We got the equation of this circle, and we got the radius of this. What was the radius of this circle? The equation of this circle was x plus 4 squared y minus 5 squared with the coordinates d of d, and this was equal to 10. We just got it now, a couple of minutes back. So with that said, then what is the radius if the equation is this? So which means the radius, dE, becomes the square root of this number. Becomes the square root of this number, dE. What about CD? Now, CD, you can easily get, because you already have the coordinates of C and those of D. Right, we have the coordinates of C and those of D. The coordinates of C are -6 and 11. Those of D are -4 and 5, which is x1, y1, that is x2, y2. x2 minus x1 squared, y2 minus y1 squared. CD. Distance formula. What is x2? x2 is like -4, x1 is -6, y2 is 5, y1 is 11 squared. You have this. You have this. All right. What is the answer to this? So this one is going to be, this is squared here. This is 2 the square root of 10 is the answer. So that C is squared is equal to, by Pythagoras theorem. See? Okay, just have this one. CED, if you draw here. Should I draw the correct thing? Yeah. CDE like so. Okay, so CD is 2 to the square root of 10. DE is the square root of 10. And we just need to find CE squared, and this is 90 degrees. Right, so we can be able to see that this is the hypotenuse, opposite angle of 90 degrees. So which means CE squared is the same as 2 to the square root of 10. You square that minus the square root of 10. You square that, and CE squared is 30 from this, and you can take the square root both sides. CE squared is the square root of 30, which means CE is the square root of 30 units. Okay, so this is Pythag. Okay, we found CE. We found CE. Okay. It is the square root of 30 units. Next question. Right, the equation of the circle with center P is given as this. Determine the center and radius of the circle with center P. Obvious. Let's just enjoy ourselves. Very easy distinction to get. Right, so these kinds of question you'll expect to get. So you have minus 14x plus y squared minus 2y equals minus 46. So you have x squared minus 14x plus half into minus 14. You square these plus y squared minus 2y. So you square these equals minus 46. So you have the half of minus 14 is 49 plus 1. So y minus 1. This is 4. Okay, look, what is the center? So you can say the center is the coordinates 7 and 1, and the radius is 2 units. Right, so point A has the coordinates. This lies on the circle. Determine the equation of the tangent to the circle at A. Determine the equation of the tangent to the circle at A. Okay, this one is a point that lies on the circle. So you have the circle. It is like center P, and then there is a point A that is having those coordinates. What is the gradient of PA? Okay, P has the coordinates 7 and 1, and you can easily, okay, determine the equation of the tangent to the circle. So you need to find the gradient of PA, which is y2 minus y1 over x2 minus x1. x1, y1, x2, y2. y2 is the square root of 3 plus 1. y1 is 1. x2 is 6. And x1 is 7. So you have this one here is 6 minus 7, which is minus 1. So it's minus the square root of 3. So that the gradient of the tangent Okay, because of this, the gradient of the tangent must be the opposite of this in sign, so it's positive, but also is the reciprocal. The reciprocal, so now to find the equation of the tangent is going to be such that it touches the circle at one point, but the tangent surely would pass through a point. It passes through these 6 in the square root of 3, 1. And then you use the formula y minus y1 equals m into x minus x1, which means we have y minus, okay, it passes through this point, which is going to have contain the points for us. The coordinates of x1 and y1, it means y1 is the square root of 3 plus 1. The gradient of the tangent is 1 over the square root of 3 into x minus x1 is 6. Okay, you need to simplify everything here. Right, if you simplify everything, what we're getting is that y is 1 over the square root of 3x plus 1 minus the square root of 3. So y is 1 over the square root of 3x plus 1 minus the square root of 3. Okay, obviously, if you are to consider the point B, that is the coordinates this, does point B lie on the circle? So you need to check this one. Remember the equation of the circle, it's something we know already. What is the equation of the circle? It is x minus 7 squared plus y minus 1 squared is equal to 4. So now if you say this point, consider it, does it lie on the circle? So you need to take the left-hand side of the equation of the circle, and the left-hand side of the equation of the circle is x minus 7 squared plus y minus 1 squared. What is x? This is x and that is y, which means x is 8 minus 7 squared. Y is minus the square root of 3 plus 1 minus 1 squared. Right, so you square everything here. It's exactly 1, this one cancels, and then you have plus 3, which is 4. And surely 4 is the right-hand side. So you have that the left substituted, and you're getting 4 the right-hand side. And therefore, the left-hand side is equal to the right-hand side. Point lies on the circle. Lies on the circle. Next, is AB a diameter of the circle? Is AB a diameter of the circle? Because we've got A and then you have got B. Is it a diameter? So to find a diameter, you need to find the distance between the points A and B. So you know that the point A has the coordinate 6 and the square root of 3 plus 1. 6 and the square root of 3 plus 1. You have the point B. Okay. The point B has 8. Plus 1. Right. So distance. So you have this, which is x1 squared plus y2 minus y1 squared. So x1, y1, x2, y2. Right, so the x2 is 8 minus x1 6 squared. X2 is 8. It's what? Y2 is minus the square root of 3 plus 1 minus y1 square root of 3 plus 1. You square this. Okay, let's find the distance AB. Right, so dealing with the distance, AB, and we get 4. We get 4. Right, so we have seen before that the radius of the circle here is 2 units, because this is the equation of the circle. So if this is the equation of the circle, it means that the radius is the square root of 4, which is 2 units. Right. This is twice. Which is twice the radius. Therefore, AB is a diameter. AB is a diameter because the distance between A and B is 4. The radius is 2. So this is twice the radius, and therefore AB is a diameter. Right, question 13. You have something interesting. Right, in diagram 1 below, ABCD is the rectangular base of one section of the roof of a hut in the mountains of Lesotho. The isosceles triangle BEC will form another section of the roof. Right, AB is given to be 12. So AB is 12, you have AD is 8, you have EM is 6, you have BE is CE. BE is CE, okay? This is diagram 1. And then there's diagram 2. In diagram 2 below, BEC, triangle BEC from diagram 1 is folded up. Okay? So triangle BEC from diagram 1 is folded up along BC such that it is perpendicular to the base ABCD. ABCD. When the roof is completed, angle BEC needs to be smaller than 65 degrees to prevent snow building up on the roof because the suit is very cold. Determine whether or not snow will build up on the roof. So let's answer that question. First, we need to realize a couple of things, that triangle BEM is actually congruent to triangle CEM. Right, you need to realize that triangle BEM is congruent to triangle CEM because there is a right angle in there, so right angle, hypotenuse, and a side. But BM is MC. BM is MC equals 4 centimeters. So BM is MC equals 4 centimeters. So which means that we can be able to get the tangent of angle E1. Right, so the tangent of angle E1, where angle E is this one, is going to be exactly opposite over adjacent. So it's going to be exactly 4 out of 6. Four out of 6, BE. Because you know that ME is 6. Right, so it doesn't matter which of the angles you consider, but now the tangent of E1 is going to be opposite of adjacent, so it's going to be exactly 4 out of 6. And now, this means therefore that angle E1 is equal to arctan of 4 out of 6, which is 33.7 degrees. Let's look at BEC. Is equal to 67.4 degrees. Snow will build up on the roof. Snow will build up on the roof because when the roof is completed, angle BEC needs to be smaller than 65 degrees to prevent the snow from building up. Okay, to prevent the snow must be smaller than 65, but you can see that E1 is 33.7 degrees, so that BC is actually twice this angle. So, and that means that snow will build on the roof because for the snow not to build, it must be smaller than this, needs to be smaller than this to prevent snow from building up. But since it is more than 65, the snow is going to build on the roof. Next question. Right, to determine DEC as shown in diagram 2, angle DEC. Determine angle DEC as shown in the diagram. Let's find that one. Okay. DM. Okay. DM squared. DM squared is 12 squared plus 4 squared. DM squared. DM squared is equal to 12 squared plus 4 squared, because AB is 12. So you have that AB is 12. And you have that AD is 8. AD is exactly 8. So now I want to find DM, right? Which means you can be able to find DM straight away. But this is a rectangular base. So which means that if this one is 12, that also is 12. And if that is true, you can find DM squared. So that means at this point, DM squared, and this is 4, is equal to 12 squared plus 4 squared. And what is this? And this actually implies that if you take the square roots, DM squared square root is the square root of 12 squared plus 4 squared. DM 4 to the square root of 10. In triangle EDM. So which means D is squared. D is squared. D is squared now can be determined because we found DM squared. So which means that we need to find D squared in triangle EDM. So D squared is going to be exactly 6 squared plus 4 to the square root of 10. Check that one. So D squared is actually 6 squared plus 4 the square root of 10. This one is 4 the square root of 10. That is the length of DM and the 6. So you can find DE squared by Pythagoras. And this means DE squared square root is 6 squared plus 4 the square root of 10. You square this. DE. So DE becomes equal to 14 centimeters. So now at this point we found DE. So you look at the diagram. So DE is this one. When you found DE to be 14 centimeters, then we need to find now the sine of DEC. Okay, the sine of DEC is going to be actually, because this is perpendicular, right? So it's going to be exactly opposite of hypotenuse. You have it. You have the sine of DC 12 out of 14. So we have this, which is DEC. Arc sine of this. And this is 59 degrees. Using a calculator. Right, because they wanted us to determine DEC. So you can see that sine of DEC is 12 out of 14. So the sine of DEC is actually 12 out of 14 because it is actually this angle you are interested in. Right, and therefore it is the opposite over the hypotenuse, which is 12 out of 14. So now the last question in the exam, question 14, the diagram, you have O represents the origin, and A is a point on the line with equation f of x equals minus 2x. A is a point on the line. A is a point on the line with the equation that. So this one is like f of x is minus 2x. That is the equation of this. B is a point on OA, so that OB is a square root of 125. E is a point on the y-axis, so that EB is perpendicular. EB is perpendicular to, yes, my dear, to OA. All right, yeah, I'm going to give us a couple of minutes, my dear. All right, my dear. Right, so that E is a point on the y-axis, so that EB is perpendicular to OA. Right, D is a point on the line with equation y equals, D is a point on the line, and the equation is 2x. C is a point on OD. C is a point on OD, so that EC is parallel to OA. EC is parallel to OA. Determine the coordinates of B. Okay. Okay, we continue. Determine the coordinates of B. What are the coordinates of B? Sometimes the examiners are trying to be creative. Right, the coordinates of B there. What are the coordinates of B? Let's just find this. Right, first and foremost, we can write the coordinates of B in the form. When X is there, the Y component is this. When X is whatever it is, the Y component is this, because B lies on the equation minus 2x equals f of x. So we can be able to find the distance OB. So which means that the distance OB. Okay, obviously O is the origin. So the distance OB, this one is x1, y1, and this is like x2, y2. So which means that you're going to have x2 minus x1 squared plus y2 minus y1 squared. Okay, we're finishing. This is the last question, and then we can take a break. Right, what is x2? So x2 is x minus x1, 0 squared. Y2 is minus 2x, and y1 is 0 squared. Goodness me, going on. Right, and therefore this is the square root of what? X squared plus 4x squared. And OB is the square root of 125. Right, so you have that. This is x squared plus 4x squared equals OB, but OB is the square root of 125. Okay, under the square root, we're going to get what? We're going to get 5. X squared is 125. And we have x here. Divide by 5. Take the square root, is plus or minus 5. What are the coordinates of B potentially? So there are two possible values of x. But because B is plus, now is plus or minus, B is on the negative x. X is negative on the left of the origin. So which means that B will have the coordinates y. Substitute x equal to minus 5 into f of x is minus 2x. Okay, there's this one minus 2x. X is minus 5. So which means is minus 5 is minus 2. X is minus 5, and this is 10. B will have coordinates minus 5, 10, like so. Next. If B is given, determine the area of trapezium OBEC. Okay, might be the last question. Let's just check. Never mind. What the additional space? Okay, if B is this is given, determine the area of trapezium OBEC. Right. If B is this, we found B to be having the coordinates minus 5 and 10. Determine the area of trapezium OBEC. Let's check. OBEC, that is a trapezium. How do you find the area of a trapezium? We say the sum of the parallel sides multiplied by the perpendicular height. So we'll first have to find the gradient of OB. What is the gradient of OB? Okay, B is this one. B is this with the coordinates minus 5, 10. O is the origin. So what is the gradient of OB? Is 10 minus 0, 10 minus 0, minus 5 minus 0, minus 2. So which means the gradient of OB is that, okay, if the gradient of OB is minus 2, we know that obviously the formula we're using for the gradient here is change in y, change in x. Okay. The gradient of OB is -2. What is the gradient of BE? Equation. So, because they're perpendicular, these OB and BE. OB and BE, OB and BE are perpendicular. That's why the gradient of BE is 2. But what is the equation of BE? BE passes through the point B with the coordinates. Equation of BE. Equation of BE. Goodness me. Y minus Y1. Okay. All right. B. Okay. This is through B with coordinates -5, 10. So which means Y minus 10 equals 1/2 into X minus that. Half X plus 5/2 plus 10. Which means Y is a half X plus 25/2. Right, so we found the equation of BE. And then now, let's see. After I found the equation of BE, we continue. What are the coordinates of E? Because this one is going to be the y-intercept. Because E is like the y-intercept. So, which means, therefore, the coordinates of E would be x0, y is 25/2. What is the gradient of EC? What is the gradient of EC? The gradient of EC, because these are parallel to each other, so the gradient of EC is equal to the gradient of this, and the gradient of this is -2, so the gradient of EC is also -2. And continue. The gradient of EC is -2 because of the notion of the parallel lines. What would the equation of EC become? So it's going to have the same y-intercept but different slope. So for C now, let's check. C is here, and it's going to be the point of intersection of this line, because you have this line here and this line there. So obviously this one is g of x equals 2x, but this one has the equation y equals -2x plus 25/2. So they intersect. So we need to find the point of intersection for C. So we're going to find the point of intersection just below. Which is -2x plus 25/2, which is 2x. X is 25 out of 8. Right. If X is 25 out of 8, you substitute into any of the 2X or this one equation, and then you'll be able to obtain that Y is 25 out of 4. The coordinates of C, the point of intersection, is going to be X is 25. We'll start by writing X, and Y is 25 out of 4. Then you have the distance is C. So that the distance EC is equal to the square root. Okay, 25 out of 8 minus 0 squared plus 25 out of 4, because we're looking at EC. So E0, 25 out of 2, and C would have 25 out of 8, 25 out of 4. But okay. This is that because we're using the fact that this one is x2, which is 25 times the square root of 5 out of 8. Okay, that is the distance formula, but it produces that one there is the distance of EC, and therefore the distance EC is 25 the square root of 5 out of 8. And then now we need to find the distance BE. The distance BE which is okay, B minus 510. Okay. Right. Obviously, we are concluding that that's x2, x1 squared, y2 minus y1 squared. Okay. Just a note, we have the B minus 510. What is E? Okay, the orientation is not accurate, please. 0 and 25 out of 2. So if you want to find BE here, so this is x1, y1, this is x2, y2. What is x2? x1, y2, y1. So the distance here is going to become 5 to the square root of 5 out of 2. What is the area of the trapezium? Provided more space here for us to finish off the question. Remember to clearly indicate additional space, all questions. So you realize if they did this in June now, in May, because some students wrote now in May this year, they're going to very likely provide extra space. So you have the trap, but this is additional space, all questions. Remember to clearly indicate the question that you used the additional space to ensure that all answers are marked. So you must label, clearly indicate at the question. Remember to clearly indicate at the question that you used the additional space to ensure that all answers are marked. So you need to indicate and clearly label your answers, not just answers, but is question what. Right. So in other words, area of trap, area of the trapezium, you can write. You can write properly here. So area of trapezium is half into the sum of parallel sides multiplied by the height. Okay, so what are the parallel sides? Right, so the parallel sides here would be, go back to the figure. The parallel sides will be EC plus BO. The perpendicular height EC plus BO. The perpendicular height is BE. EC plus BO. EC plus BO. The perpendicular height is BE. The perpendicular height is BE. So the area of trapezium what is this? What is EC, for example? The distance of EC is 25. Square root of 5 out of 8 is 25. The square root of 5 out of 8 plus BO. What is the BO? OB, we found OB before. This here. OB is the square root of 125. OB is the square root of 125. It's even given in the question. OB is the square root of 125. OB is the square root of 125. Can continue and finish off. BE, now the perpendicular height. BE, the perpendicular height is 5 to the square root of 5 out of 2. 5, the square root of 5 out of 2. So area of trapezium is, okay, you multiply all this and it becomes 1625 out of 32. And this is approximately 50,8 square units. Area of trapezium. Which means the area. $50 units. 50 units squared. Okay. Any other additional questions? These are all blank. So we found that the area of the trapezium is 50,8 units squared. Okay, I must thank you for joining us. I think that I'm gonna take a break now. It's just 19 past 11. So it has taken us just an average of about 3 hours, so just slightly below that. And then we're gonna see you. We're gonna meet again when we can meet again.